Okay, you have a circle here, and the radius is 1 unit. That's why it's called the unit circle. Okay? Now, in Cartesian form or coordinate form, this point here is called xy. Okay, can you remember from complex numbers what it's called? It's not xy, it's cos theta and sine theta. Okay, we'll explain how you get that. So if this is your angle theta, okay, so we're interested in x, okay, so sine of theta is opposite over hypotenuse, so that would be y over 1, so y is sine, and cos of theta is adjacent over hypotenuse, so that's x over 1. Okay, so x is cos and y is sine. So another way of writing this is cos theta and sine theta. Okay, so you can find that point as long as you have this angle. You might remember this from complex numbers. That's my angle theta there. Okay? If I'm interested in this, how do I get to that? 180 minus, okay, whatever this is. Okay, so if we're calling this bit here theta, then this would be 180 minus theta. What if I wanted to get here? I have to go all the way around to there. If that's theta, how would I get to that? 180 plus theta, good. And then here, 360 minus theta. Okay, do you remember that? Okay, great. Now, using the unit circle, we can find that reference angle theta, and then we don't need to worry about any of this, okay? So, if we have an angle in here, okay, sine of 45, cos of 45, tan of 45, it's all pluses, okay? So do you want to take this down? Yeah. And I'll start drawing something else. Okay, so if we're looking for an angle, we can just use our reference angle theta, and the only thing that changes is the sign. Okay, so this is important that you need to learn. Okay, C-A-S-T. Cos is positive down here. Sine and tan will be negative. Here, all of them are positive. Okay, sine of 45, tan of 45, cos of 45, they'll all be positive in here. Over here, only sine will be positive, and here, only tan will be positive. Okay, so for example, will you take this down first? Really important, and you need to learn it. Okay, let's say I'm interested in the angle 30. Okay? So, sine of 30 is a half. Cos of 30 is root 3 over 2. And tan of 30 is root 3 over 3. They're all positive. Okay? Now, if I'm interested in 30 over here, what's that the same as? 180 minus 30. So the question could ask me for 150. And I know that 150 is the same as 30, but I'm over here in this quadrant. Now I know this is C, A, S, and T. So if I'm asked for sine of 30, I'm just going to write out the answers again so that we don't have to keep going back. Okay? If I'm interested in sine of 150, okay, I know that's the same as sine of 30 here, and sine is a plus. So my answer to sine of 150 would be a half. But my answer to cos of 150 would be what? It's the same as cos of 30, but over here, it's a minus. So sine of 150 would be the same. It's a half, it's a plus. Cos of 150 is the same, root 3 over 2, but my sine is a minus. And that would be the same for tan. Okay, what about down here? So my 30 is in there. So the question might be sine of 180 plus 30. Come on. So the question is sine of 210. What is sine of 210? Well, I know that is sine of 30 in this quadrant. Okay, down here only tan is positive. So sine of 30 is a half. So in this quadrant, sine of 210 is minus a half, because sine is minus down here. Tan of 210 would be root 3 over 3, and because tan is positive in this quadrant, it would be a plus. Is that okay?
I think you're still using the answers for...
Because the angle 30, it's the same wherever it is, okay, on the unit circle. Your answer stays the same, it's only the sign that changes, as in SIGN, plus or minus, that changes. Okay, so you're always using that reference angle because the reference angle doesn't change depending on the quadrant. All that changes is the sign of the angle. Okay, so you're always going to use your reference angle, which is going to be less than 90, and you're just going to see, is it in here, which is theta, over here 180 take theta, here 180 plus theta, or 360 minus theta. All right, will I put an example into your copy? Okay, find sine of 120. Your calculator absolutely does this for you, but we may need this to answer more questions. Okay, so sine of 120, if I draw it, where is 120 going to be? Not here, it's going to be over there, isn't it? So that's 120. So what would this be? 180 minus 120, which is 60. So my reference angle is 60. Okay? Now it's 60, and I'm going to write in my C, A, S, and T. So what's sine of 60, first of all? Sine of 60, root 3 over 2. So sine of 120 is going to be root 3 over 2. I just need to decide whether it has a plus or a minus. Now, it's here, and sine is a plus there, isn't it? So it just stays as root 3 over 2. Are you okay with that? Now you can just go to the calculator and type in sine 120 and the answer comes out for you. But we still need to know this, okay? Now, cos of 225. 225 is bigger than 180. Okay, so it's going to be in here. So here it's 180 plus something gives me 225. So that's going to be 45, isn't it? So my reference angle is 45. I'm down here in the tan quadrant, so only tan is positive. So I know cos of 45 from my log tables or my calculator is root 2 over 2. So cos of 225 is root 2 over 2. And I just need to decide what sign it's going to be. So down here, what sign is cos? Cos is a minus, isn't it? So cos of 225 is minus root 2 over 2.
How did the cos get the same?
So that's what I'm saying. 45 anywhere, so 45 there, and 45 there, they're all the same, root 2 over 2. So it's either here, it's a plus root 2 over 2 if we're talking about cos, okay? So this would be cos of 45 plus root 2 over 2. Over here, it would be a minus root 2 over 2, okay? Okay, example 2. Can I get rid of the board? Find cos of minus 135. When you have a minus angle, it means you're starting here and going this way. Okay? So that's minus 135. What would that make my reference angle here? Yeah, so you could say 180, take 135, which is 45. So I'm interested in 45 there. Okay? So, cos of minus 135 is actually the same as cos of 225. Okay? So we're interested in the reference angle 45. Okay? Cos of 45, C-A-S-T, down there is going to be a minus, isn't it? So that's what, sorry, cos of 45 is that. Cos of minus 135 is your minus. So figure out what your reference angle is and then figure out the sine of it. And just, are you okay? Sorry.
How is this minus if it's maybe in the quadrant?
How? It's, oh no, so it's nothing to do with this angle.
Okay.
It's all to do with the reference angle.
Right.
Okay? So it's to do with what quadrant is the reference angle in. Okay? Part 2 of this, which is going to lead us on to the next thing that we're going to do. If sine of x is minus root 3 over 2, find two values of x if x is between 0 and 360. You're going to draw your 4 quadrants and mark in your CAST. Now, sine of x is minus root 3 over 2. So sine of the angle is a minus. So that tells me, where is my reference angle? In the T and the C quadrants. Because it's a minus. If it was a plus, they'd be up there, but it's a minus, so it's down here. So I know my 2 reference angles are in there. Now, how am I going to find what my reference angle is? Sine of x is minus root 3 over 2. So how would I get x? Pardon? Sine inverse, yeah, shift sine. And I'm just going to do the root 3 over 2. Not interested in the sine, because I know the sine has already told me where it is. Okay? So I know that x is 60 degrees. But it's 60 degrees down here. 60 there, or 60 there. So if it's 60 there, my first angle is what? X is from there to there. How do I get it? 180 plus 60. Good. Okay. So x there is 240. Or it's here. How do I get to that? 360. Good. Take your 60. So that's 300. So find 2 values of x if x is between 0 and 360. So there's my 2 values of x.